who's now the care advisor at Cambridge, and he said we should be thinking about activity, not exercise, and I found that very helpful actually.
And I think we find we mention the word exercise and we can see people like glaze over, and that's why we really talk about making it relevant to the person, and it has to be something that you enjoy. So if you enjoy being in your garden and being active in your garden, but you don't enjoy kind of being on a bike, that's fine. You find that way to get that kind of that stimulus by doing a different activity to somebody else.
So hoovering.
Yeah, absolutely. But if that does
being realistic, it's like, what do I do that I can call exercise now?
Yeah,
just open up a whole new mindset for me.
Absolutely. So don't
things that I do every day, but actually exercise.
If that if that gets you up and gets you active and gets you to the point where you feel a little bit out of breath, then that is your exercise. But it's that consistency and that pacing. So what we don't want people to do is kind of push themselves to the limit and then not be able to do anything for the rest of the day. You could get the music on, you could do a bit of a dance on it.
You couldn't dance for about 2 days after, so
can't stand hoovering, but I love music, so chair dancing.
Absolutely.
There is the marker for when you will be done it, that your urine changes colour. So this is something that's come up in
never get it there.
But we're not recommending you exercise at that level.
But I've come across people with children who say, my son loves running, but then he pees this stuff and it looks like coke.
Yeah.
There are some conditions, some form of muscular dystrophy where it can occur more often than in others. But yes, that certainly shouldn't be, if it happens every single time that you exercise or hoover.
Does that mean you're overdoing it?
Yeah. But mostly then you don't want to damage your kidneys, so make sure if it happens that you drink enough water.
I think it's mostly for people, who have maybe got the genetic condition but haven't yet noticed a lot of symptoms, so they are pushing themselves.
Well, it does happen also in people who have a diagnosis, and some are more prone to have that happening. And sometimes as children that is very difficult to pace it
to tell them to start running about.
Kind of pacing and I had a good word in my head and it's gone. Pacing and consistency, I think, are the two biggest things that I would try and encourage people to think of in terms of their activity levels.
It's sometimes very difficult though, because if you're living, unfortunately, with a back defect as well, so you've got chronic pain for your back, you've got no cartilage, your hips have gone as well, and you get chronic fatigue from having this. Sometimes you're very fatigued, but then when you have a day where actually you think, actually I feel, not too bad today, I try to do more, because it's maybe the only day that I've got that week where I can do more. But unfortunately, the next day, as my husband said, it's your own fault. But I like exercise, and it really frustrates me. So I like to do swimming, but when I go, I tend to do too much because I don't get that often.
That's where,
and I really love it.
And this is where we say, when you think about going swimming, again, it's not thinking, right, I've got this one opportunity to get in the pool, so I need to do 20 lengths. Getting into the water, even walking. So there's lots of things you can do in the pool that will still give you that kind of that stimulus of exercise and physical activity, but won't kind of push you to the point where you're so fatigued that you're done in for the next 2 days. So things like sidestepping in the water, marching on the spot in the water, squatting, holding onto the side. So you might not be able to squat on dry land because your knees might not let you do that, but in the water, when you've got the support and the buoyancy of the water, and for some people, that feeling of being able to do something in the water that you can't do on dry land, it has that physical benefit, but also it's nice to be able to do that.
I do them before I swim and then after I swim, before I get out, with the physio gave me them. They're really good.
So there's lots of things you can do in the water that you still get the exercise, you still get that effect, but you're not so knackered that you can't do whatever you need to do.
But for some of us, getting into the pools is huge.
And we've actually kind of, it's a big discussion that we've had in terms of accessibility of pools, and I think I'm sure we did a bit of a scoping exercise as to looking for accessible. And MDUK,
so MDUK has, if you Google MDUK pub, you'll find this as a finder of either neuromuscular centre, gyms, pools that are accessible. Now I don't know, we would need to ask Rob how updated it is. Some of our patients that we had referred to some of those centres and said actually maybe you had to pay, or you had, so that wasn't, they were maybe were accessible but not
free.
Not necessarily free, or not every day, so maybe it was during from low season, or when it depended on the centre. So it's still helpful to have that possibility to search and then inquire.
But I certainly do appreciate that sometimes it's the actual it is, and also access to hydrotherapy is
non-existent.
Sparse, and it would be lovely, and but again, I think it differs from region to region. But we certainly see with the patients that we try to refer, trying to get hydro is.
I looked in my area. There's a dog hydrotherapy pool. Oh, not one for humans.
Well, they do have them in the hospitals, but they just don't have the staff to do it.
Yeah.
It's just, that's it.
Yeah, my difficulties, because I used to go swimming 6 days a week, is the hard thing I haven't figured out yet from my change is getting on it and getting the swimming costume on. To me, that seems like the full gym session before I even get into the pool. Yeah. And I'm just wondering if there's any groups or anything that could help me get changed. My brother's a big support, but obviously I don't want him coming and changing me.
I mean, and I think, again, Joe's quoting me on this, I'm not the best person to speak to. Joe probably has more information, but there are, if you do get PIP or the different kind of benefits, some of those can be used to, to employ a PA to maybe come and help you to do those.
That's dreaming.
That's what I said, don't quote me on that.
The give you is so tiny. It's just enough to be able to live your life.
Right.
It doesn't pay for extras.
Yeah.
It really doesn't.
And I know kind of getting support to do those kinds of activities is really, really difficult. And that's why if anybody has any little pockets of information of, any success stories of if people have managed to get support to do things like that, then please let us know, because it is something that we hear regularly. And with my physio hat on, I can stand here and I can say, right, you should do this, you should do that. But that's in an ideal world, and it is trying to problem solve and look for alternatives and look for things that actually is realistic.
The support, I mean, you can try to have some peer support groups. And MDUK has had, I don't know if they still do that, actually Rob mentioned they have peer support groups in different regions, so maybe through that you may find someone also volunteer, someone else that can help. But other charities, in the area where you live, there might be charities that we can ask if there's any volunteer that could come with you, whether it's one, I don't know how frequently it is, but even if it was that once a week to access pool and help you getting changed for a few hours.
Because it's a shame, isn't it, that people are missing out on doing activities like that, because it's the difficulty of accessing it, not actually being in the water, but actually getting dressed to get in and accessing the pool itself.
I think as well, just to pick up on that, I think accessing a PE is a task in itself as well. I would agree with that. Yeah.
Not that sounds awful, but I just haven't got the finances for it. I know people. I mean, I've had a couple of offers. No, I'll be a PA, but I haven't got the money to pay somebody such a big wage.
Yeah. Even if you do manage to get an award for a PA, this is different because my daughter has a lot of mental health issues. I managed to get an award for a grant to find a PA, but then tried to find a PA. I tried to find a PA who's consistent and reliable.
Yeah.
So you end up being the PA because you get less time to do your own stuff because you're trying to enhance their life.
And it all has a knock-on effect, doesn't it? Kind of the issues going on in social services with, care provision, PA provision, and then being able to access things in the community. So it is a difficult time for accessing things, and we need, I guess, to be realistic but be a little bit creative and think outside the box of whether there are other ways. So Kiara said about the pedals. So it is about thinking, right, well, if I can't get to the pool, what could I do instead? So you can get the little pedals that go on the floor, or the you know, so it's just thinking of other things that you can do.
Yeah, I've got my own like mini gym at home, but I know it's not enough because I'm putting weight on and it's helping. So,
It is, and it's easy to get into this.
Yeah, cycle.
Yeah.
Could I, from the 100% unable to exercise, I have an overhead hoist in the bedroom. A piece of material round the bar, so I put my wrist into it, raise my arm up above my head. It stretches my rib cage up, stretches my arm. It makes breathing, it improves my capacity to breathe. And do the other hand the other way. You get it up. So I'll do it. What I would like to do, I'm thinking of, I'm not mentioned to remember this yet.
Probably involve me.
Well, yes, or somebody. If I could put, it sounds like I'm going to bondage, it's terrible. Getting both wrists in at the same time, so somebody could take up so both arms went up, so I got an even stretch.
I mean, when I talked about thinking outside the box, I hadn't considered tying yourself to a hoist to give yourself a stretch.
I had the good fortune that when I was working in London, I went to the Queen Square, which is excellent Europe, one of those places, and I got really good at them. They were very strong, up over the head, expansive wrist,
And for people who do spend most of their time in the wheelchair, I appreciate that exercising and moving around is difficult, but it can be, if you're unable to kind of move yourself in your chair easily or regularly, if you've got a chair that, the tilt in space, the recline, if you're able to spend a bit of time with your legs up, even those little changes of position regularly will help kind of, postural management and ease any aches and pains, because, if you move around, if you're able to move around unaided without difficulty, we wiggle, we change position all of the time. That's just what our bodies are designed to do. And if you have weakness, if it is difficult to move, sitting in one position at a time is hard work. So using the different modes on your chair can help just open up your hips, lie down for a little while, sit up for a little while, put your legs up for a little while. All those little things can just help just manage some of the day-to-day aches and pains. Are we being...
Yeah, can I ask you one question? Right. I'm moving, I finally found a bungalow that I can use my e-tricycle to get to the gym and the swimming pool. That's why I'm doing it. I'm future-proofing my life. But when I get to the gym, whenever I've gone to a gym before and done the induction thing and put you in all these machines, I've fainted before with the pain. Where can I go when someone says, if you've got muscular, these are the sorts of exercises you should be trying to do in the gym, not the one that some gym buddy that's really fit can do, because I could have done them when I was championship mountain biking when I was in my 20s, but I'm not now. I'm almost 60 and I've got this stuff and my knees don't work, my hips don't work, my heart doesn't work very well and can't breathe. But there must be something that I can do. I want to do what I can do.
And this is where it's really, really difficult, especially, we hear people who are willing and they've got the desire and they've got the motivation, but there's the gap of the provision.
I don't have the knowledge of what I'm supposed to do, and I don't know who to access.
So some community physios will help support development of an exercise programme in a gym, at home. I can't comment on each particular service because I know different localities have different kind of stresses, strains. They used to do it like exercise on prescription, but again, people still don't necessarily have that understanding of you. I don't know whether from an exercise or pain management perspective you've got.
Exercise for pain management, or we need a diagnosis of the pain. So once we know why the pain's there, then we'll give the exercise for that. So before, when I was giving all those percentages, that's specifically about getting out of breath exercise. So that's not about dealing with the pain. So when we're trying to deal with the pain, it always comes back to, well, why is the pain there? Can we work out why the pain is there? Can we address the pain?
I can work through pain and pain all the time.
Yeah.
But it's just, if it gets to the point where I faint with it, that's not good for anyone.
No, definitely not.
But, and we wouldn't recommend doing an exercise that results in that pain. But it's about what, I suppose, maybe we need to examine your pain in more detail.
That's good. You sorted out my tennis elbow.
Well, I've use an example.
Yeah, fantastic.
That's got nothing to do with getting out of breath.
But it was probably a repetitive strain.
For the injury,
but it's more
making it better.
Yeah,
so it's about working out why the pain's there.
I think if you're from locally, I think there's
Oh yes,
massive repercussions.
Okay, so we'll start. So I don't know how the session ran before, but we're happy to be guided by you. So if we introduce ourselves, and if you've got any questions off the top of your head, we can deal with them. If you don't, then we've each of us got a few slides that we can share and answer any questions or have any discussion that arises after that. So as you know me from the previous session, I'm Lizzie Harris and I'm a genetics doctor. So I work mainly in the diagnosis of LGMDs and overseeing the diagnostic process and that side of things.
Hi, I'm Yolanda. I'm one of the team of scientists that work as well on diagnostics. We analyse muscle biopsies to see what sort of changes are occurring in the proteins.
I'm Esther. I work in the basic research team and we were trying to understand the progression of the disease in muscle dystrophies and how cells are different from patients to healthy controls.
And I'm Anna Top, I'm a researcher at the center, and I work in all the genetic analysis that we do for all the patients that were not diagnosed through the NHS pathway.
So we cover everything from getting a diagnosis through the NHS to if you don't have a diagnosis, how we might find new genetic causes of limb-girdle muscular dystrophies, and then also working on finding new treatments for LGMDs. Has anyone got any burning questions that they would like us to start us off with?
Just that I've had some emails from people who are unable to attend, and one lady has emailed me just to ask, she's interested in clinical trials and doesn't know where to go. I don't know whether that's relevant to what you were thinking, but I just thought I'd throw that in as a question so I can go back with the answer.
So does she have a diagnosis?
She does have a diagnosis, and she's interested in clinical research and trials.
So I think from everyone here, we're not actually the kind of clinical trials team.
Yeah.
So I would find out what her diagnosis is, and then you could ask.
I realised it wasn't one of the things,
but you're welcome to.
It up as part of the workshop because it wasn't appropriate for the last one.
So you could pass her details on to Michaela and ask, or give them to me. But I'm not very plugged into which clinical trials are open and which are recruiting. Is that a question that other people have? Or Lindsay,
I was going to add in and like also encourage them to look and see if there's a registry. Yeah.
Like I said, I know it wasn't what we were talking about there, but it was just a question that, how the questions that have come in.
I suspect it's a question that other people have as well. Is that a question that other people have generally? Or
contact registry, which one do you mean?
Yeah, about clinical trials that are recruiting for their specific disease.
Would that be open? Where would you go? Which website would they go to look on? So they just,
There's basically just do a general search in the first instance. Some of the registries will be listed on clinicaltrials.gov, and then there's
Treat an MD will also guide you to patient registries, but there's another very good one which is LGMD awareness, and if you look them up, they have a really a long list of registries which are suitable for each individual disease area, and that's always improving. So, but yeah.
Thank you, Lizzie. I'm sorry to
please do ask questions, even if it doesn't seem directly related to what we're talking about, because this is an opportunity to
I don't know if this is relevant either, but my husband is got put on a high blood pressure tablet, and it was really bad for him because he's not right. I just wondered if you knew, or who would be the best person to ask for it. Like, they won't put him on another blood pressure tablet, and his blood pressure's still quite high, and they're obviously frightened that the same thing happens again.
Yeah.
Because a lot of the symptoms he had from it has deteriorated him. One of them being limb weakness, slurred speech, and low blood pressure.
Low blood pressure,
yeah, so he was hypothermic and all the things he shouldn't get.
Yeah.
The drug.
And was that the GP that prescribed
that
it?
was, but it was a new doctor that knew nothing.
Yeah.
I just wondered if there was, because like obviously we're monitoring it and it's still really high.
Yeah, which is
and just wondered if there was someone that we could speak to on who know about, blood pressure.
So I guess there isn't. I don't think there's any specific reason why you would have a bad reaction to a particular blood pressure medication based on having a limb-girdle muscular dystrophy. You would think that it would be reasonable to try a different one and see how you go, but
we're scared of doing that.
Yeah.
The doctor's scared. The doctor's
scared
to put him on another drug because of the adverse reaction.
Yeah.
Because of all the boxes on the back. He had about 10 of the boxes. Now, Eddie never takes medication, so this was really about first time, apart from like creams or ointments for his legs and that. He's not been on a lot of medication, so we know that it definitely came from that. And when we read all the things on the back, from hypothermia, he was in a space blanket and whatnot.
Oh, goodness me. Yeah.
I was only in for one night, but it sorted me out.
Yeah.
But,
I took him off that drug right away.
Right away, and I hit right up in the wrist things, several in the 1 in 10,
and
several.
This is still the result from 6 months ago.
Into the 1 in 10,000.
All of the same. Yeah. And have you seen your local neurologist and sort of this?
Well, they're now waiting for a hospital appointment. Yeah. I just wondered if anybody knew of, or this had happened to somebody else, and there was a blood pressure tablet that was.
Yeah. Well, what was the tablet? Was it a beta blocker?
Wait, you got
the name here, but I can't remember it.
Fortunately, that man is a GP, and he happened to phone and correctly said, Eddie is a 999.
Amlodipine.
Yeah. So I would say there isn't any specific reason why that medication would have an adverse effect on you.
My friend,
muscle weakness.
Because of muscle weakness, he said
should never
avoid any weakens the muscles. I did mention that to the doctor. So they put me on it. And one of the things it says is may cause muscle weakness. And
so I think it's probably important that you get assessed by the neurologist just to see how you were compared to pre-having that tablet, and then after that it may be that they'd be able to advise your GP about trying a different blood pressure medication. Because obviously it's important to have the blood pressure treated as well, but you don't want to do something that's going to make you...
Just be careful what you're given. Read the back of your prescriptions.
Okay. Anything else that anyone wants to quiz us about? So should we start? So Yolanda, we're not in any particular order, but Yolanda's going to start. So she'll talk to us about what happens in the muscle immunoanalysis unit.
As I said, I'm part of a team that works in diagnostics of Newcastle Muscular Dystrophies. So we get muscle biopsy samples referred to us from all over the country, and it's a service that's free to access in England, Scotland and Wales. So basically we'll take the muscle biopsy, cut it into very thin slices, and then stain them just to get a picture of how the muscle actually looks. So this is what we look at under the microscope. So we stain it just so we can visualise all the different fibres. And essentially what we're looking for is to see any changes that are different to normal. So we've got normal skeletal muscle on the left-hand side here. You can see that the fibres are fairly uniform shapes and sizes. And then when you have patients with muscular dystrophy, the appearance is slightly different. You get different types of cells involved. So you've got sort of inflammatory cells. You get sort of more of your fibrotic changes, and you can get fat cells appearing, which shouldn't normally be there. So that's our first sort of clue that something's gone wrong at a genetic level. And then we analyse the proteins within the muscle to see if we can find anything again that's glaringly wrong. So we use antibodies, we apply those to the tissue, and they bind to the proteins that we're interested in visualising. So again, in normal muscle you will see something like a dysferlin. This sort of brown deposit is what we were looking for. And in a patient with dysferlinopathy, it's completely gone. So we can see sort of gross changes like that, and other times you just see sort of slight amounts of patchiness in the labelling, or just sort of reductions or the change in where we see it. Another test we can do is a Western blot. So we sort of crack open the cells of the muscle biopsy essentially, and you end up with super proteins, and then we run them on a gel to separate them out. And again, that gives us clues. Sometimes you have proteins that are completely absent. Again, in the case of dysferlin, there's a missing band there. And sometimes they're just slightly shifted, they just appear different.
Why are there parallel columns?
Because we run more than one sample on a gel. So something on the left is more of like a normal control, and then the one on the right would be like the patient sample. And we have quite a unique technique of testing more than one protein at a time. So we have a cocktail of antibodies that we apply to the gel that we've run.
And that's why you can get more to test for different types all at the same time.
Yes. Similarly with the immunohistochemistry that you do on the sections, we cut lots of different sections and we test lots of different antibodies. And the combination of information we get from that helps us determine how the change in the gene affects the proteins in the muscle. So previously, in previous years before the advent of sort of next generation sequencing, we were sort of the first step in the process. So we would have a look and see what's likely to be wrong, and then that would direct the genetic testing. But now you can test for so many genes at once. So we're really sort of in the background, but still important in the sense that you could find a variant in a gene and you don't really know what effect it has on the muscle or the protein in the muscle. So it's still an important piece of information that helps get to a final diagnosis and see how that genetic change actually affects your muscle. Thank you.
So I have a couple of slides just talking about what is the pathway for patients where we don't manage to find a genetic diagnosis. So I spoke earlier this morning about this genomic testing, so testing lots of genes all in one go. So what we would tend to do for someone, if you came to clinic and you had an LGMD type pattern of weakness and a history that sounded like that, then we would do this first test that looks at 80 different LGMD genes and some that look, some genes that cause conditions that look very similar to LGMDs. Just sort of based on our experience, we know that there is a lot of overlap with some other conditions as well. And then, if we don't find a diagnosis on that, then the next step would be to do this thing called whole genome sequencing. So that is analysing all of your genes. So we've got 23,000 different genes, but we focus in on several hundred of them that can cause neuromuscular conditions. So it's not just looking at the LGMD genes, but widening the net further. So just thinking more broadly, because we know that actually just based on looking at someone, sometimes it's quite hard to distinguish one particular genetic condition from another. So we just sort of look at as much as we kind of practically can. If we still don't find a diagnosis, so there are patients where we go through both of these processes and we still don't have a genetic diagnosis for them, so the next step would be to include them in a research study that tries to find their genetic diagnosis, and that might be that they've got a change in a gene that we know about, but for some reason that particular genetic change we didn't think was the answer for them, and we can go back in a research setting and just spend a bit more time looking in detail and looking at those kinds of changes. And the other option is that they might have a completely new disease that we've not known about before, so looking for new genes that can cause LGMDs and conditions that present in similar ways. So there's two kind of ways that we can do that kind of genetic research. So one is quite new, which is called the National Genomic Library for Research, which I'll talk about. And the other way, which we have done really up until now and are still doing, is doing other kinds of genomic sequencing research projects, which Anna will talk to you about in a minute. So the National Genomic Library for Research, so apologies this doesn't show up there, the writing's quite small, but what it's basically showing is that a patient, so someone who comes to clinic where we want to do whole genome sequencing to try and get a diagnosis for them, as well as having their diagnostic testing in the NHS, they get the option to be included in the National Genomic Library for Research. And this is quite newly set up, so it's just started really in the last year. And what we're doing is getting people's genetic sequencing and all of their personal information, so not just about your muscular dystrophy, but also about whether you have high blood pressure, high cholesterol, hearing problems, whatever that may be. And all of that information is anonymised and held together in this, what they call a research library. And a bit like Lindsay was saying about the registries, that people make an application to access that data, and then there's a steering committee that decides whether or not that is an appropriate application. It's the same kind of process here. So for the research pathway, someone makes an application. That might be someone from a university in the UK, somewhere else in the world, an academic institution. It could be a private company, a pharmaceutical company who want to find people with a particular genetic diagnosis or do some other research. And if they're approved, then they get access to this library of anonymised genome sequencing information and personal health information. So they can do that for research into muscular dystrophies, but also for research into anything actually. So if they want to look at a new treatment for high cholesterol, they could use this library for that as well. So this is the consent form for the National Genomic Research Library. So there's quite a few bullet points. So I don't know, anyone may or may not have gone through this because it's quite recent that we've started doing this, but there are some issues that are sometimes worth thinking about. Do you mind pressing on the next slide, please? Thank you. So whenever we do any kind of whole genome sequencing, we always talk to people now about how you might find something that is unrelated to the reason why you're having that test. So particularly if we're looking at muscle disease genes, occasionally we find a change in a gene which might increase the chance of, say, a heart condition, but isn't the cause of that person's limb-girdle muscular dystrophy. So we would still tell you about that because that's important for you and might be important for other members of your family. So that's a kind of incidental finding, which isn't your diagnosis, but it's just something we've happened to find and we need to tell you about. So we try to give people forewarning that that might happen, so that these things don't come out of the blue completely. For the National Genomic Research Library, some of the things that come up when we discuss this with people is about the security of stored information. I know, like in the news, there's sometimes been like high-profile leaks of data, and we really hope that that wouldn't happen here. But for some people, that is something that makes them pause before taking part. There's also a question about how truly anonymised your information is. If you've got a very rare disease and you're the only person in the UK with it, then it's not really completely anonymised. But of course, your name and your date of birth and address isn't on there, so it's just about understanding that. Some people have concerns about their personal data being accessed by private companies as well. I think probably we understand that we have to work constructively with industry if we want to have, like, you know, treatments developed and trials funded, etc. But for some people that sits uncomfortably. And when you consent to take part in the National Genomic Research Library, you consent to have your personal information collected across your whole lifetime and beyond. So even after you die, they may still be collecting information. I'm not sure what new information they will get. But when you consent to something over that time frame, you know, it's worth just thinking what might change in terms of what is possible through genetic technologies, or how your own personal feelings might change about that. You can, of course, withdraw from this at any point as well, but it does pose some interesting questions.
Excuse me, sorry.
Okay, so I'll pass on to Anna unless anyone's got any questions.
Say it's possible to withdraw, so at any time you can just completely
at any time. I think there's a form to fill in, so if you wanted to withdraw, you just get in touch with the person that consented you in the first place.
How would you know that your information wasn't being squirreled away somewhere?
What do you mean?
What would be the? How can you guarantee that
if you withdraw, that it's really withdrawn? I don't know. I think you have to trust that the.
Well, see, that's an issue. I mean, I'm not talking personally, but I think for some people that would be an issue. Well, if I've given my data, how can I possibly know that can
it's being deleted,
be completely returned to me?
I think different people have different views on that, don't they? And for some people, that would be a sticking point. I saw someone recently, and they had, you know, a diagnosis unrelated to possible muscle diagnosis, and they were concerned about private companies being aware of that, and you know that was going to, how that information would be used. So lots of people just sort of agree to these things because they're very trusting, but some people ask a lot of questions, and I think quite reasonably.
We have heard about data breaches, and there are unscrupulous companies who would be mining for that information.
I think that quite often we dealt with correctly.
The initial pathway that the patients with muscle diseases and muscular dystrophy go through, and up until the point where this genome library that Lizzie was talking about, the only way that we had to try to understand the disease cause of a patient that couldn't be diagnosed by the NHS lab was to include them in one of our research projects. So I work in the basic research strand, and I do all the what is called next generation sequencing studies, that are the exons and genomes that we apply for undiagnosed patients. And what we do is we recruit these patients into one of these research projects. We've got a number of studies running. They could be studies that are led by us, where there are mainly local patients or UK patients. We also are part of very large European or even international studies in different continents, where we look at patients that have a muscle condition, limb girdle muscular dystrophy, or other muscle conditions, and that are still undiagnosed. To be included in one of these projects, the patients will have to sign a consent, similar to what Lizzie was saying, and some of the things that I'll mention are the same idea. So the patient has to know that this is voluntary, there is no, you can decide whether you want to be part or not, and that again you can withdraw from the study at any point. We also need to collect the clinical data, and this data is anonymized for the same reasons. We need the clinical data to be able to match genetic information with clinical information and see if that makes sense when we get a result later. And then something else that if patients sometimes say a muscle biopsy for research purposes, that's not that common to happen, but maybe a skin biopsy is helpful as well, because we can use the cells from the skin to do some tests later on. It's not exactly the same as the muscle, obviously, but sometimes we can still use it, and that's obviously less intrusive, less painful. So patients might be asked for a sample like that. Then we do a test, and this is an exome or a genome or a transcriptome, and these are assays or experiments where we look, as Lizzie was saying, we look at all the genes that are in the genome. We do the analysis of that, and we It's similar to what the NHS does in a way. We start looking very small, so we look first at a number of genes that are known to be associated with muscle disease, maybe 100 genes. If we don't identify anything in those, then we move, we expand the search, as we say, and we look at 500. And if nothing is found, not even very rare or cryptic changes in known disease genes, we start to look at anything else. So when we say anything else, these are genes that are not known to be associated with muscle disease. But for whatever reason, because the genetic change seems to be pathogenic or seems to be deleterious, we think, well, this might be involved in this disease. But that's not enough. If we have a suspicion that a mutation might be involved, we need to do some functional validation. And this is because the gene is not known. So for functional validation, we can do cell culture, as Esther will talk later. So this is looking at the cells and see how the cells behave. We compare the patient cells with normal cells and see if the presence of that mutation has an effect on the muscle structure, for example. We can look at animal models and do different things to see if this new gene that we identified really seems to be the genetic cause of the disease. Once we have that, because this is all in a research setting, that's not enough, because we're starting to have some clues about what's going on. What we need then is to find similar cases, so similar patients that have changes in the same gene and that present with a similar clinical presentation. So we start to match. It's, again, as Lizzie was saying before, it's a little bit of a puzzle here. We try to get one patient is not enough, but if we've got 2 or 3 or even more that have similar clinical symptoms and mutations in the same gene, there's a stronger indication that this is indeed, if it's validated by functional data, that this is indeed a new disease gene. If we manage to do that, then we get a publication in a research paper, and that one actually that is there is a new gene that we discovered, that is a new limb girdle muscular dystrophy that we identified in our center. And once that is in the field and is known, then that leads to the diagnosis of the patient, but also feeds into the analysis again, because now we have a new gene that can be analyzed from the beginning. It's not just new, it's just part of the genes that are known to be associated with muscle disease.
So that's how you can keep expanding the types of LGMD that you're finding.
Exactly.
That's why we've had to rename them all, because you've got past 26.
Exactly. Yeah. Yeah, that's the reason. Yeah, that's what we do.
Any questions for Anna, anyone? No? Okay.
So I'm also working in the basic research strand, but I'm in the side that we study proteins and how these proteins behave and how they are different in muscle dystrophies compared to healthy controls. So we basically work with muscle samples that have been already diagnosed in the MIU and in any of Anna's projects. And what we are focusing in our group is trying to understand the progression of the disease. So what is known so far is that in early stages of the disease, the muscle is well preserved, but as the disease progresses, there are different cycles of contraction and injury in the muscle that promotes that different cells that are not muscle cells can migrate into the muscle. So for example, in the muscle then we can find immune cells, inflammatory cells, fibroblasts or adipocytes that are the cells that will promote the increase of the fibrogenesis and adipogenesis in the muscle. So what we can do is analyzing the structure of the muscle by muscle histology. And as you can see here, there are differences in the muscle histology. While in healthy muscle, the structure is more or less well preserved, and there is a common structure of the muscle. In histology of a muscle dystrophy, you can find an increase of fibrotic areas, that would be these ones like here, or adipogenesis. And we try to understand which proteins promote that increase in adipogenesis and fibrogenesis in patients. So we basically work with muscle biopsies from patients, And we try to understand what are these changes. So apart from staining muscle slices from patients and healthy controls, we can also work with the cells from the muscle. So for example, we can isolate cells from muscle tissue. We receive a piece of muscle from the NHS, and we can cut this muscle into small pieces and culture these small pieces into the cell culture. So by just culturing this in proper conditions, we can obtain different type of cells that reside in the muscle. And with these cells, we can isolate them and try to find the differences of the proteins that promote these changes in muscle dystrophies, and try to see if there is any potential drug that can stop progressing the disease. So as an example of an ongoing project that we are doing, we are using muscle cells from patients, and we are trying to find potential drugs that can stop the progression of the disease. So as a first step, we set up a high throughput screening test, which is basically try thousands of compounds that are already approved by the FDA, and see if these compounds can have an effect in the cells of the patients, so if they can change the behavior of these cells. So from this high throughput screening, we can focus on those drugs that we see that they have an effect, and keep working with just these drugs. So as a second step, we try these drugs that we have seen that can have an effect in cells in vitro. So we use these drugs to treat the cells from the patient in culture and see how they stop promoting adipogenesis or ferrogenesis in vitro. And once we found which drugs has a good toxicity effect and a good cell effect, we can move on the third step, which will be to do a preclinical study. So in the lab, we can work with mouse models that can reproduce the phenotype of the disease. So there are different mouse models that have the sarcoglycanopathies, like Duchenne or Becker, or there are lots of different models, and we can use them to treat them with the drug that we have been working, and see if these mice progression of the disease is slower, and if the muscle function test is better than it was without the drug. So this hopefully at some point will arrive to clinical trials in which we can analyze the effect of the drugs that we are trying in cell culture, and see if these drugs can find drugs that stop the progression of the disease. Our idea is that these drugs at some point could be a combinatorial therapy with with gene therapies, in which gene therapy can restore the genetic mutation, and our drugs can promote to increase the regeneration of the muscle and to help with the disease progression. This is basically what we do in our lab.
Any questions about any of that, or anything that needs clarification?
Set up some mouse models. That means that these mice has the mutation that promotes the genetic variant that we're interested in. For example,
so the mice have been bred to have that particular type of muscular dystrophy.
Exactly, the genes have been changed, so they have, for example, with Duchenne, they have the dystrophy mutation. Yeah. With dysferlin, they have the dysferlinopathy mutation that are found in patients, so they can. The phenotype of these mice are similar to patients in terms that they have muscle weakness, they reproduce some phenotypes that are seen in patients, and it's like the previous step to go to clinical trials to try the drugs in mice models to see if...
I remember seeing a video a couple of years ago at an MD UK conference of two mice, one of which had been treated with the gene therapy, and it was in the wheel. And
exactly.
But even some of the people in the room needed it to be explained to them what they were seeing. Mm-hmm. You know, I'm seeing these two mice had the same illness. This one has been treated, this one hasn't. Mm-hmm. Look how fast this one can now run. You know? Yeah. And it gave me, you know, something to be hopeful about. So that was nice.
So after treating the mice with the drug or with the gene therapy, what we normally do is muscle function test, which can be the wheel or there are small treadmills for animals or the grip strength for animals, and you can see the changes with or without the drug in the different groups of animals.
So where are we now from, like the mice to people? What are we?
So for example, all the gene therapies that are now in clinical trials have been previously tested in mice.
So the trials are now getting
just beginning.
Just beginning.
Right.
But what's exciting about this part of Esther's research is that she's using finding drugs that are already known about, so not developing something new like gene therapy, but seeing drugs that are already used for other conditions that we already know the side effects for, and seeing do they have effect? Do they have another effect? Because they've never been used to treat muscular dystrophy before.
They're all drugs that have got approval.
They've got approval for other indications.
And fairly cheap to produce, presumably. Relatively cheap to produce.
It would certainly be cheaper than gene therapy. I don't know what's on your list of compounds. Yeah. So Esther, do you want to say like how many of the drugs that you tried you've got through to each stage?
Yeah. So we started with almost 500 compounds. On the first step, we narrowed to 8 compounds, and we are finishing this step. We are closer to the clinical studies, and we are going to go with 4 of these compounds. So let's see.
4 to try in the mice.
4
to try in the mice. Different muscular dystrophies.
With different ones, right? Okay.
And it's nice because it's something that could apply to all muscular dystrophies because they all have this common feature of fibrosis.
So 4 approved drugs that are already on the market for different things, you trialled, and now out of 500 you can now discover what you can take forward in the next.
Yeah. So it's this idea of repurposing drugs which are already used for something else.
And to actually get approved for once, if any of them are successful, to get that approved would be so much easier.
That's it. Yeah, we already know that they're safe in humans.
Was the first objective to find some drugs that are already commercially available because then it's everything easier and faster.
Yeah. And then the idea that in the future it might be that there's a combination of different therapies, like we see potentially for SMA, which I know not an LGMD, but in a genetic condition, we see patients of where there is gene therapy, but there's another therapy, and thinking about how you might use things in combination to, for the best possible effect. Yeah.
Going from, when I was diagnosed, there were no treatments. There's no treatment. It's a long way that we've come in that 12 years.
It is a long way, isn't it? I was saying that to someone at lunchtime, from my side, looking at the genetic testing, it's great that in the NHS we have really good genetic testing now. And the same with treatments, much closer to the horizon.
Light years from when I was done 50 years ago.
50 years ago. 50 years ago.
50 years. I was a teenager, young, lower half of the teens, and now 66. Sorry. The current medication makes it difficult for me to speak.
That's all right.
At times.
Yeah. No, it's really interesting because we do see multiple generations of people, and because all the genetic, finding the genes has only been in the last 50 years, hasn't it? And less than that. So there's people where they've had a diagnosis of a particular condition before we even knew that the gene existed, and then we found the gene.
People were misdiagnosed, weren't they, with lots of other different things.
Yeah, that's it. So we're getting much better at finding the diagnosis, and then the next thing is, of course,
my family might be quite interesting for you.
Okay.
2 of my cousins also have limb-girdle.
Just recently found, though, they're older in age.
They're both working farmers.
Right.
My mum and their dads are the Cohen family. My dad is a complete outsider. Their mums are both complete outsiders. And I know that, I think it was this Glasgow centre teachers, and they say, this odds says you're far more likely to win the lottery than to hit what we've hit. They really thought, we've done this wrong. This can't be happening.
Yeah, the odds
We're
are
so rare. So I was thinking, I reckon you want to speak to me. My mother had multiple sclerosis. Her sister died from multiple sclerosis. And her brother, he was ready to die. He had something funny as well. So, yeah.
Yeah. Well, it's interesting that, you know, the chances of winning a lottery, lots of people have said that today, because of course you know, when you've got a rare disease, you feel like, well, it could happen because it's happened to me. It changes your perception.
So one of the issues that we have, I'm sure other people find the same, is because it's a rare disease, no one's heard of it. Even now, even you know, we've got further with the diagnosis, there are more people on the registries, that kind of thing. People have heard of multiple sclerosis. They all think it's the same thing. But getting people to even say limb-girdle muscular dystrophy is quite hard. So I think there is an issue with communication and, you know, talking to the outside world.
And I think for talking to like making sure you get the best care from the healthcare professionals that you see, the registries, and having the ability to develop standards of care that you can point people to, I think is really helpful, because then you don't have to be seen in a centre with lots of experience, because you can say, well, this is what I should be having, and it's easier for them to follow, you know, for other people to follow.
How many GPs do you think have never seen somebody with MD?
With a muscular dystrophy, probably most GPs haven't seen someone with a muscular dystrophy.
So heaven help the public, they will never know.
That's it, because the ignorance is within the professional, not just the general public.
And it's a problem that's common to all like rare genetic diseases, I think, is the feeling that you have to explain yourself to everyone that you come across, and that can be quite wearing. And you know, if you have, you know, we're fortunate we've got a specialist nurse, and, you know, if you get admitted to hospital here, we can communicate with the team. But if you don't have that kind of setup where you are, you know, it can feel like a little bit of a battle, I think, probably having to explain yourself everywhere
Tom moved to Newcastle.
Goodbye!
Horn cell disorders, peripheral neuropathy, disease of